So the question is quantum confinement results in. So we'll be solving the question from a chemistry aspirant point of view. We won't be going into the deep concepts, okay? We won't be discussing the non-trivial concept. So we would be solving each and every question, right, from the from our trivial concept basically, which is common to each and every chemistry aspirant. Okay, so that is the basic point of view. So how we'll be using our basic knowledge and how these concepts will actually help us in figuring out or in finding out the correct answer. Okay, that is the important point of these question series. So the question is quantum confinement results in. Now let's say, okay, I am guessing that we are not clear with the concept of quantum confinement. Okay, so how we would be solving the question of quantum confinement. So the question is quantum confinement results in. So we have four options, and in four options there's a relation developed between energy gap and the size of the system. So that is what we need to do. Now what is quantum confinement? Okay, that means it has something to do with the quantum mechanics. Okay, and next is they are using this term energy gap. Okay, so one term is quantum. Okay, second term is energy, that is clear from the question, and third term is semiconductor. Okay, third term is semiconductor, and the fourth one is size of the system. Okay, so this is what these four terms basically we have in the question. Now we know this concept semiconductor is actually when we used to study physics in our 12th standard, we have studied semiconductor. Okay, it has something to do with electrons and holes, right? Am I right on this concept? It has something to do with electrons, holes. Okay, p and n type of junctions, np type of junctions, right? I'm sure you can recall this concept. Okay, so it has something to do with electrons and holes. Okay, and if we have electrons and if we have quantum, okay, so we can understand this concept. That means the concept is basically your electronic wave function. Okay, it has something to do with electronic wave function as well, right? Quantum, then we have electrons, it has something to do with electronic wave function. We know this thing from quantum. Okay, let's take an example of particle in a 1D dimension box. Okay, so we have electron in a one dimension box. Okay, and what is going to be, what is the energy relation? Energy relation is n square h square 8 ml square. Okay, this is the energy relation from quantum mechanics for particle in a box. Okay, particle in one dimension box. So in this particular question, axis is not defined, dimension is not defined. Okay, so I'm taking an example of one dimension box, or you can take example of two dimension, three dimension, doesn't matter. What we have to figure out, we have to figure out the relationship between the energy and the size of the system. Okay, so what you can observe over here, for electronic wave function or for electrons, energy is inversely proportional to square of length. Length means size of your system if it's one dimension. If we have one dimension, so we can say this length is actually the size of system, right? So energy is inversely proportional to square of size of the system. Okay, so what we have four options. Energy gap in semiconductor, because in semiconductors also we use the term of electrons. Okay, we have electrons as particles, electrons and holes. Okay, so we are using the electronic wave function or energy of your electrons. Okay, for electronic wave function. So energy gap in semiconductor is proportional to inverse of square root. No, this is absolutely incorrect statement. Energy gap in semiconductor is proportional to inverse of size. No, and energy gap in semiconductor is proportional to square of size. And then we have the fourth option, energy gap in semiconductor is proportional to inverse of the square of size. Okay, that's how we can solve the question. See, in TIFR examinations, most of the questions are conceptual. Now over here, just as from chemistry point of view, let's say I don't know the concept of quantum confinement. Okay, so how would I solve this question? This is the way I would have used the concept, I would have used the keywords given in the question, and then we can arrive to the answer. Okay, so what we have used: quantum, energy term, semiconductor, size. From energy, we came to the conclusion of basically electrons. Then I have used the energy relation of electrons, then the relationship between the energy gap and the size of the system. Okay, so length is also known as the size of the system. This is how we can use the keywords and we can come to the final answer, that is option D. I hope I'm clear on this question. Let me know in the comment section if you have any queries.